Hello, this is Dr. Hanaa Assil, and these are questions and answers on qualitative analysis or tests for anions and cations and gases and so on for the IGCSE chemistry. So let's take a look at the first question. The first question says aqueous sodium hydroxide is added to two different solutions. He added sodium hydroxide to solution X and he got a green precipitate. And the question is, which cation gives a green precipitate with sodium hydroxide? You should realize that that is iron 2. Iron 2 is the one that gives green precipitate with sodium hydroxide. Now he added sodium hydroxide to solution Y and he got a light blue precipitate. Which cation gives blue precipitate with sodium hydroxide? The only thing that gives blue is copper. Copper 2, so my answer is C. A mixture containing two anions was tested. So the first test is he added dilute nitric acid and he got effervescence of a gas which turned lime water milky. First of all, remember that effervescence means bubbles of gas or fizzing. All of these are the same. Now, if I add acid, and that is any acid, to a substance and we get bubbles of gas that turn lime water milky, this is test for what? You have to memorize these tests. This is test for carbonate. So my answer is A or B. Then he added dilute nitric acid followed by silver nitrate and he got a yellow precipitate. And you ask yourself, silver nitrate is test for what? You should remember it is test for chloride, bromide, iodide. Now, which one gives yellow precipitate? It is iodide. So my answer is B. Compound X is tested and results are shown. So he added aqueous sodium hydroxide, heated gently. He got a gas given off, which turns damp red litmus paper to blue. This is test for what? When I add sodium hydroxide and heat gently, and it gives a gas that turns damp red litmus paper to blue. This is test for ammonium, because when you add base to ammonium, it gives ammonia gas. So this is test for ammonium. Then he added dilute acid and he got again effervescence turns lime water milky. Remember that this is test for what? This is test for carbonate, and we can add any acid. So in the previous question, he added nitric acid, or here he added hydrochloric acid. If you add acid to something and it gives bubbles of gas that turn lime water milky, that means I have carbonate. The results of 3 tests on a solution of compound X are shown. What is compound X? Okay, he added sodium hydroxide and got a white precipitate soluble in excess. He added aqueous ammonia and he got white precipitate soluble in excess. He added hydrochloric acid and he got bubbles of gas. Now, first, which one gives white precipitate soluble in excess with both sodium hydroxide and ammonia? You should realize that that is zinc. Aluminium would give white precipitate soluble in excess with sodium hydroxide, but not with aqueous ammonia. So what I have is zinc. Now it is zinc what? Remember, adding acid to give bubbles of gas. That is carbonate. So this is zinc carbonate. Are we memorizing the tests as we go along? Now he's saying when sodium is burned in oxygen, what color is the flame? Remember, you are required to know the colors of flame tests. So what are the colors of flame tests? Lithium is red, sodium is yellow, potassium is lilac, calcium is orange red or brick red, barium is light green, copper is blue green. So if he has sodium ions, which color does he get in the flame test? He gets yellow. That is correct. Okay, the next question says, which aqueous ion causes a yellow precipitate to form when acidified lead nitrate is added? Remember that lead nitrate or silver nitrate are tests for chloride, bromide, iodide. If it's chloride, I get white precipitate, bromide, cream precipitate, iodide, yellow precipitate. So he got yellow, that means he has iodide. Some barium iodide is dissolved in water. Aqueous lead nitrate is added to the solution until no more precipitate is formed. So he is adding lead nitrate to what? He's adding lead nitrate to something that has iodide, and that means he should get yellow precipitate. Remember, lead nitrate or silver nitrate with iodide gives yellow precipitate. So X is yellow. Then dilute sulfuric acid is added to the filtrate. The filtrate has what? It has barium something. Barium something with something that has sulfuric acid. Remember that dilute sulfuric acid is the acid that has sulfate. So barium something with sulfate will give a white precipitate. Okay, he's saying two tests are carried out on a solution containing both copper sulfate and sodium chloride. Which results are correctly recorded? Okay, so he has copper sulfate and sodium chloride. He added barium chloride. Is barium chloride test for what? You should realize the barium chloride is test for sulfate. So we have sulfate. What should we get? We should actually get a white precipitate, not a blue precipitate. So test 1 is wrong. I am adding barium chloride to something that has sulfate. I should get a white precipitate, not blue. Then test 2, he added silver nitrate. Again, silver nitrate is test for what? It's test for chloride, bromide, iodide. Which one do I have? I have sodium chloride. That means I should get white precipitate. So that result is correct. The next question says aqueous solution S is added to aqueous ammonium. So he's adding something to something that has ammonium. The mixture is heated. Ammonia gas is given off. What is it that we add to ammonium to give ammonia gas? This is the test for ammonium. We add what? We add a base like sodium hydroxide to ammonium salt. It gives ammonia gas. Which two compounds give a white precipitate when their aqueous solutions are mixed? Which of these, if I mix them together, they give white? You should realize that silver nitrate with chloride would give white, and that means the first solution would give white precipitate. Silver nitrate with iodide, which is option B, would give yellow, not white. Sodium hydroxide with copper something would give blue precipitate. Sodium hydroxide with iron 2 something will give green precipitate. So my answer is A. Aqueous sodium hydroxide is added to solid X. The mixture is heated. He got a green precipitate and an alkaline gas. Now, if I add sodium hydroxide to something and I get a green precipitate, what do I have? I have iron 2, so Fe2 plus. So my answer is A or C. But then if I add again sodium hydroxide to something and it gives me an alkaline gas, the only alkaline gas we have is ammonia. So if I add sodium hydroxide to what? To ammonium, I get an alkaline gas. So my answer is A. Do we understand how to think about these questions? He says aqueous sodium hydroxide and aqueous ammonia each give a white precipitate when added to aqueous zinc sulfate. What happens when an excess of each of these reagents is added? So I have what? I have zinc something. And I'm adding first sodium hydroxide. What should I get? I should get white precipitate soluble in excess. So the precipitate should dissolve. What if I add aqueous ammonia? I get the same thing with zinc. With both of them, I get white precipitate soluble in excess, giving colorless solution. So in both cases, the precipitate dissolves. Then the next questions are from paper 3 or paper 6, which need short answers. So a precipitate may be formed when two aqueous solutions are mixed. So again, if he says what is meant by precipitate, it is a solid that is formed from reaction of two solutions. The color of these precipitates may be used to identify particular ions. So for example, to test for iron 2, do you remember the test for iron 2? Well, we can add aqueous sodium hydroxide, or we can add aqueous ammonia. So if we say we add aqueous sodium hydroxide, what do I get with iron 2? And here he's saying just write the color of the precipitate. So he already tells you that it's a precipitate. You just need to write the color. You should remember with iron 2 I get green precipitate. What about test for iodide? What do we do to test for iodide? Dilute nitric acid plus aqueous silver nitrate or lead nitrate. And we said with iodide I get yellow precipitate. What about chloride? The same test. Dilute nitric and silver nitrate or lead nitrate. You choose one of them. With chloride, what should I get? A white precipitate. What about test for sulfate? What was the test for sulfate? You remember? Add dilute HCl and aqueous barium chloride, or dilute nitric acid and aqueous barium nitrate. So you need barium chloride or barium nitrate. If I add it to something and it has sulfate, what should I get? A white precipitate. Then you have questions that are just directly telling you to write the test. So for example, describe a test for calcium. We actually have 3 tests for calcium. So you can say add sodium hydroxide with calcium, it will give white precipitate insoluble in excess. Or you could say aqueous ammonia with calcium, what would that give you? Aqueous ammonia with calcium gives no precipitate or very slight white precipitate. Or you could say flame test. So you could tell me do flame test. What is the flame test for calcium? What do you get? Brick red or orange red flame. So if I say aqueous sodium hydroxide, with aqueous sodium hydroxide, calcium gives white precipitate insoluble in excess. What if he says describe a test for copper? Copper ions. If we say add aqueous sodium hydroxide with copper ions, what should you get? Light blue precipitate insoluble in excess. What about if he says describe a test for hydrogen? What was the test for hydrogen gas? Insert a lighted splint, it pops. So remember the test for hydrogen gas was insert a lighted splint, it pops. What was test for chlorine? And remember that we have test for chlorine gas and test for chloride ion. What was the test for chlorine gas? Insert damp blue litmus paper, it bleaches. Remember when we test for gas, we have to use damp litmus paper. That means you should have water on the litmus paper, because litmus will not work unless if there is water somewhere. Then some questions will tell you, describe a test you can use to distinguish between 2 things. So he's saying here I have ethene and methane. Which test can you use to distinguish between ethene, which is an alkene, and methane, which is an alkane? When you do organic chemistry, you realize that the ethene is the one that has double bond between carbon atoms, and the test for that is add bromine water. So we said if we add bromine water with any alkene, it turns from reddish brown to colorless. With anything else, there is no change. So remember that any alkene, ethene, propene, butene, pentene, if you add bromine water, it turns from reddish brown to colorless, or you could say it turns from orange to colorless. While anything else like methane, no change or no reaction. Describe a test for ammonia gas. Again, you have test for ammonia gas and test for ammonium or aqueous ammonia. So what is the test for ammonia gas? It is insert damp red litmus paper, it turns blue. Remember that ammonia gas is the only alkaline gas or basic gas that we talk about. Describe a test for iron 3. What was the test for iron 3? Please memorize as we go along. What is the test for iron 3? Add aqueous sodium hydroxide, we get a reddish brown precipitate. Remember, iron 2 gives green, iron 3 gives reddish brown precipitate. Describe a test for aluminium ions. What was the test for aluminium ions? Add aqueous sodium hydroxide. What happens? White precipitate, soluble in excess, giving a colorless solution. Are you memorizing? Okay. Describe a test for chromium. What was the test for chromium ions? Again, add aqueous sodium hydroxide. What is the result? Green precipitate, soluble in excess. So this is the difference between iron 2 and chromium. Iron 2 will give green precipitate insoluble in excess. Chromium gives green precipitate soluble in excess. What was the test for iodide? Are you with me? Dilute nitric acid and silver nitrate, and we get a yellow precipitate. What is the test for carbon dioxide gas? We said bubble the gas through lime water, it turns milky. Then we have this kind of questions where he says, describe a chemical test to distinguish between each of the following pairs of substances. So he wants to distinguish between water and ethanol. In this kind of questions, you're supposed to mention a test that works with one but not the other, or a test that gives two different results with the two substances. For example, if I want to distinguish between water and ethanol, I can say add anhydrous copper sulfate. Now, this is test for which one? This is test for water. So with water, I will get, it turns from white to blue. With any other substance, I have no effect or no change. Okay, what if I'm trying to distinguish between sulfuric acid and sodium sulfate? Now, you do realize that sulfuric acid and sodium sulfate, both of them have sulfate. So I cannot do the test for sulfate because both of them will give me the same result. But what is the difference between them? Sulfuric acid is an acid. So I can do a test for acid in which we say add a carbonate, be specific, let's say sodium carbonate. Now with the acid, I get bubbles of gas that turn lime water milky. But with anything else, no effect or no change. Remember, if both of them have the same thing, you cannot test for that because both will give the same result. So here you cannot test for sulfate. What if I'm trying to distinguish between hydrochloric acid and nitric acid? Now here both of them are acids, so I can't say add sodium carbonate. Both of them would give me bubbles of gas that turn lime water milky, so that will not distinguish between them. But what is the difference between hydrochloric acid and nitric acid? Hydrochloric has chloride, nitric has nitrate. So you should be able to do test for one of them. So let us say if I say add dilute nitric acid and aqueous silver nitrate, this is test for which one? Test for chloride. The one with chloride will give white precipitate. The other one, no effect. Or I could do the test for nitrate. In that case, it's the nitric acid that will give me a result. The other will not. Distinguish between copper sulfate and copper carbonate. Again, both of them have copper ions, so you cannot do the test for copper. Both of them will give the same result. But the difference is one of them is sulfate and the other is carbonate. So you either do the test for sulfate, then the first one reacts, the other doesn't. Or you do the test for carbonate, then the second one reacts and the first one doesn't. So here, for example, if I say add dilute hydrochloric acid, I'm doing the test for what? For carbonate, then the sulfate will have no effect. The carbonate will give bubbles of gas that turn lime water milky. Do we understand how to answer this kind of questions? Okay, this is another kind of questions where he says, this is usually towards the end of paper 6, he says a solid D, which is soluble metal sulfate. So I have something sulfate, and he's doing the tests. Now, the first result says appearance is pale green crystals. Remember, appearance tells you, do I have transition or not? So if it is green, that means what? That means I have transition metal. If it is white, solid or colorless solution, then there is no transition. Okay, so we have a transition metal. Now solid D was heated in a test tube gently and then strongly. We got condensation at the top of the test tube. Remember, if he says that he heated the solid and he got condensation at the top of the test tube, what does that tell you? It is a hydrated salt, or it has water of crystallization. Don't just say it has water. It has water of crystallization, or it is a hydrated salt. Then he did tests on solid D, several drops of aqueous sodium hydroxide, and he got a green precipitate. Excess sodium hydroxide, the green precipitate remained. That means it's a precipitate insoluble in excess. When he added excess aqueous ammonia, again he got green precipitate. So which one gives me green precipitate insoluble in excess with both? This is iron 2. So this tells you that I have iron 2. Then he says he added silver nitrate and nitric acid. Again, he's adding it to what? Remember that previously at the top of this, we said it is a metal sulfate. So he's adding silver nitrate and nitric acid. Again, you're going to ask yourself, silver nitrate is test for what? It's test for chloride, bromide, iodide. Do I have any of that? No. That means I have no effect or no change. Aqueous barium nitrate and dilute nitric acid. Again, this is test for what? Test for sulfate. Do I have sulfate? Yes. If I have sulfate, what should I get? White precipitate. So, after the table, he gives questions. What does test A tell you about solid D? Which one was test A? So let's go back to test A. Test A was the one where he said it is a pale green crystals with condensation formed at the top of the test tube. So that means that it has transition metal and it is a hydrated salt. What conclusions can you draw about the identity of solid D? We found that it has what? Remember, he did tests and he found that it has iron 2 and it is hydrated. So the identity or the name of solid D is hydrated iron 2. Remember, you have to mention that it's iron 2, not iron 3. This one says I have two liquids, L and M. L is potassium iodide. M is a colorless liquid. Okay, potassium iodide. What is the appearance of potassium iodide? When he asks you for appearance, the first thing you ask yourself, does it have transition metal? Potassium iodide, this is a compound of group 1. Would you expect a compound of group 1 to be colored? No. Then, if it is a solid, we say white solid, but in this case it's a liquid, so we say colorless solution. Then he did tests. He said an iodine crystal was added to the first portion of liquid L. The test tube was stoppered and the contents shaken. The liquid turned orange. What does that tell you? He added iodine and the solution turned orange. That just tells you that the iodine dissolved in the solution. Remember, iodine solution is orange or reddish brown. Then he says an equal volume of liquid M, the contents were added, the contents shaken, and he got 2 layers. That means he added a liquid M and it formed 2 layers. That means the liquid is not miscible with water or with the previous solution. That means it is most probably an organic liquid. Remember, when we have organic liquids, they are not miscible with water, so they form 2 layers with water. So the second portion of liquid L, here again, let's go back and see what was liquid L again. It was potassium iodide. He added dilute nitric acid and barium nitrate. Okay, again, barium nitrate is test for what? Test for sulfate. Do I have sulfate? No. Then that means I get no effect. I don't have sulfate. I have iodide. So the third portion, dilute nitric acid and silver nitrate were added. Again, silver nitrate is test for what? Chloride, bromide, iodide. Which one do I have? I have iodide. Iodide should give yellow precipitate. Are we following? Why does the color of liquid L change? That was when he said he put the iodine and the iodine dissolves in the solution to give an orange color. What conclusions can be drawn about the liquid? We said it was not miscible. It formed two layers. That means it must be an organic compound or an organic liquid that is not miscible with the solution. Are we following how to think about all of this? Okay. Then this next question says, I have a mixture of two solids, M and N, and he's saying solid M is zinc sulfate. Can you see that? It is water soluble, and that means if he adds distilled water and shakes, then this is the filtrate. So solid M was made into a solution, and this has zinc sulfate. So if he has drops of aqueous sodium hydroxide, again, we're adding it to what? To zinc sulfate. I'm adding sodium hydroxide to something that has zinc. What should I get? White precipitate, soluble in excess, giving a colorless solution. What if I add aqueous ammonia with zinc? Exactly the same result. White precipitate, soluble in excess, giving a colorless solution. Remember, zinc gives the same result with both. Now, if I'm adding dilute nitric and silver nitrate, again, silver nitrate is test for what? Chloride, bromide, iodide. What do I have? I have zinc sulfate. So I don't have any of this, no effect. What about if I add dilute nitric and barium nitrate? Barium nitrate is test for what? For sulfate, and I do have sulfate. If I have sulfate, what should I get? White precipitate. Are we following? Then he says the appearance of the residue is a black solid. If I tell you that something is black or any color, that means it has transition metal. He added acid. The mixture was heated. The gas given off was tested, and he says he got effervescence. Again, I'm reminding you, effervescence means bubbles of gas. Pungent gas, bleached litmus paper. Which gas bleaches litmus paper? You should realize that it is chlorine. So when he asks identify the gas given off in this test, it is chlorine. Then he added hydrogen peroxide, and it gave off a gas, effervescence, and glowing splint relit. Which gas relights a glowing splint? Oxygen. I'm going to remind you that hydrogen peroxide in this syllabus is just used as a solution to which I add a catalyst and it gives off oxygen. So if I add something to hydrogen peroxide and it gives off oxygen gas, that means that thing is a catalyst. So if he says, what conclusions can you draw about this solid? Well, we found that it is black. That means it has transition metal, and it causes hydrogen peroxide to give off oxygen gas, so it can act as a catalyst. Okay? Again, we want to distinguish between chlorine and sodium chloride. How do I distinguish between chlorine, and in this case, he's saying aqueous chlorine, that means it's a solution, and chloride. So if I say add dilute nitric acid and silver nitrate, this is test for which one? This is test for chloride. So the result with chlorine is no effect. With chloride, I get a white precipitate. What if he's saying distinguish between iron 2 and iron 3? Again, which test should I add? Aqueous sodium hydroxide. With iron 2, I should get a green precipitate. Iron 3, reddish brown precipitate. Okay, this is another kind of this question. He's saying 3 different liquids, P, Q, and R, are analyzed. And he's telling me that P is sulfuric acid. Okay, so the appearance of P, what would be the appearance of P? He's telling me Q is colorless and smell of vinegar. R is colorless and no smell. Now P is sulfuric acid. So what would be its appearance? Remember, any acid is a colorless solution. It has no smell. So you follow his example. What would be the pH of P? Remember, sulfuric acid is a strong acid. So pH 1 or 2 or 3. Now, what about Q and R? What is he telling me about Q and R? He's saying Q is smell of vinegar. Remember, which one gives us a smell of vinegar? You should remember that that is ethanoic acid. And pH 5, that means it's a weak acid. So that is ethanoic acid. So he is telling me that Q is ethanoic acid. It has smell of vinegar and it has pH 5, which is a weak acid. What about R? He's telling me R is something that is colorless with pH 7. What do we know that's colorless with pH 7? It could be a salt or it could be water. Okay. The next question says he added a piece of magnesium ribbon was added. The gas given off. He's adding magnesium ribbon to what? P we said is sulfuric acid. So if I add magnesium, which is a metal, to acid, what should I get? It is something that will give hydrogen gas. So I will see rapid effervescence, because for the other one, he's saying slow effervescence. Sulfuric acid is a strong acid, so it will be faster. So you either say rapid or fast effervescence, where the gas is hydrogen gas, so it lighted splint pops. He wants the gas to be tested. Lighted splint pops. What about Q? He said Q is slow effervescence. Well, we would expect that because it's a weak acid. Now, what about R? R, no reaction. Okay. To a little of liquid P, again, sulfuric acid, he added hydrochloric acid and barium chloride. Barium chloride is test for what? For sulfate. Do we have sulfate? Yes, sulfuric acid is something that has sulfate, so I get a white precipitate. Liquid R, he said he heated it to boiling and it boiled at 100 degrees Celsius. What does that tell you? That R is water. So what conclusions can we draw about liquid Q? Liquid Q is the one that we said is ethanoic acid and it's a weak acid. And liquid R is the one that boils at 100, so that is water. Okay. This question says two different solutions, X and Y, are analyzed, and he's telling me that X is copper sulfate solution. So, appearance of solution X. You should know what is the color of copper sulfate solution. Copper sulfate solution is blue. You have to know that. Then he says to a little of solution X, he added sodium hydroxide. So if I add sodium hydroxide to something that has copper or copper ions, what should I get? Light blue precipitate. Don't forget the word precipitate. Then he added aqueous ammonia, drop by drop, and then excess. Remember, if I add aqueous ammonia to copper something, I get what? Blue precipitate, soluble in excess to give dark blue solution. So the precipitate dissolves to give dark blue solution. This is the result of ammonia with copper 2. Tests on solution Y. He's telling me I have solution Y. It is something that has pH 1. That means strong acid. And it is something in which he added solution Y. He added a few drops of dilute hydrochloric acid and aqueous barium chloride, and he got white precipitate. Barium chloride is test for what? Sulfate. So this is a strong acid that has sulfate. Which acid has sulfate? You should realize that the strong acid that has sulfate is sulfuric acid. Okay. Okay, so this is the end of this video for now. I hope that you found it useful. Thank you for listening.